Hello everyone, welcome back to the session of cryptographic network security. In today's video, we'll be covering two topics, that is linear congruential generator and Blum Blum Shub generator. Okay, so this Blum Blum Shub, the name has come. You might be thinking, right, like what kind of weird name is this for a generation of random numbers? But it's nothing but a name of three people. Where see you have this Leonard Blum. Manuel Blum and Mitchell Shub. So their surnames were used as the name. Okay, so what are these two topics? Nothing but generation of random numbers. Okay, so first let us talk about what is random numbers. So random numbers are nothing but very some events called some physical events, like raindrops. So if it is raining and if you have kept a particular plate with a certain box, so where in which it will fall first, second, like that, it's completely random. If you shake a branch of dry leaves, which leaves will fall first, it's all complete random. If you try to observe the radio active wave particles and all, it's all completely random, like from this noise distribution, etc. But what are pseudo randoms? Pseudo random is nothing but even they are random numbers, but they have a background. What is that background? Nothing but they are based on some mathematical formula. So these random numbers are generated based on mathematical formula. Okay, so that is nothing but pseudo random number generation. So in that, the first topic is linear congruential generator. So if they ask about any linear congruential generator or Blum Blum Shub, first you have to talk about what is random numbers and what is pseudo random numbers. You will get a proper notes from the description. If the notes is not available in the description, you just have to comment or wait. You will get the description soon. Because I'm alone, I have to do everything. So anyways, yeah. Before we move on, kindly subscribe and like, man. Like, I don't understand what's the problem with you guys. You just watch the videos so completely skip here and there. You don't even like or subscribe. I don't understand what's the problem. Anyways, so you have to remember four things for linear congruential generator. Okay, you can see the introduction part in the video, how you have to start introducing. I'll only explain the actual concept, and we'll move to this next topic. We have four things: M, A, C and X naught. What is M? M is nothing but the modifier, that you take that mod some number, right? That's a modifier. A is a multiplier which you multiply with your X, and then C is the increment. Okay, X naught is nothing but the initial number or the first starting number. So it will be move on from X0, X1, X2, X3, so on, etc. So now what is the formula? Xn plus 1 is equals to, Xn is nothing but instead of 0, that is n, right? So we don't know how many numbers it's, so 1 to n. So instead of saying 1 to n, we just take n. Xn plus 1 is equals to, we don't know the initial number, that's why we are taking the xn. A into x0 plus c mod m. Okay, so here what you are doing, so basically if here we have x0, then what do we say? I'll write here, x1 is equals to a into x0 plus c, whatever the value I get, then mod that with m. Okay, for that we'll take one example in which x0 is 3. So what I can do, x1 is equals to, what is a? That is 5. Okay, so 5 into 3 plus c is 7. I'm just taking an example, even you have to remember this value. See, 3, 5, 7, 16. Okay, mod 16. Okay, so now 5 3 is 15. 15 plus 7, what is it? 22. Correct. 15 plus 7 is right? 5, 6, 7. 22 mod 16. What is the value? If you divide 22 by 16, you will get only one as answer. We are not using floating numbers, we're just going with integers. What is the remainder? That is 6. So now what I got, x1 is equals to 6. Okay, 22 mod 16 is 6. Okay, I told you one trick also, right? If you cannot you don't know how to use modulus in your calculator, just multiply this number and check the closest value, okay, to the actual number. So 16 into 22, so 1 is at 16. If you go 2 times 32, so just take 1 and subtract that number with 22. So 22 minus 16 is your actual answer for the mod. If I go with x2, x2 is equal to, so it was 6 at 6 into 3 plus 7 is the increment, then mod 16. 6 3s are 18. 18 plus 7, that is 25 if I'm not wrong. Right? 6 3s are 18 plus 7. 5, see? That's 25. If I do 25 more 16, it's the same. I have to subtract. So what answer will I get? 5. I'll get 9. Yeah. So no, I have to get 5 over here. Why am I multiplying with 3? Okay, so sorry, my bad. See, here it is 5 into 6. Okay, 5 6 is 30. 30 plus 7, that is nothing but 37. 37 mod 6. So I'll have, see, 37 minus 32, because 16 2s is 32. So what's the answer? That is 5. So this is nothing but 5. Okay. Similarly, I will go for x3 is equals to 5 into what value I got? 5 plus 7 mod 16, which is equals to 25. 25 plus 7 is nothing but 32. So 32, if it is 32, then answer is 0, because 32 minus 32 is 0, right? So there is no remainder actually. Then I will substitute 0. 5 into 0 is what? 0. 0 plus 7 is what? 7. 7 mod 16. It is 7. So x4 is equals to 7 mod 16 is equals to 7. So see, first we had our x naught is equals to 3. See 3, 6, 5, 0, 7. If you continue this process, you will get the numbers, see, like this, so on, up to 12. Then after 12, you can see the number has repeated. This 3 is nothing but the seed. So if you see here, so total 16 numbers. Okay, so what we got? 16 numbers. Now 16 is also what? Are m. So here there are some rules. Okay, so that is nothing but, if you use this algorithm or this method, you have to generate all the number from 0 till m. See, here modifier is always greater than 0. Multiplier comes between 0 and m. Incrementer can be 0 or it lies between 0 and m. Same goes with x naught. So here the rule is all the numbers should be generated till m. So if you have chosen m as 16, so 0 to 16 all should be generated. So you can see here, check all the numbers have generated, and it should be completely random. It should not repeat numbers. All those things you have to. You can just check in that in the notes which I provide, and also the advantage and limitation disadvantage. So what about cryptographic system? Can we use this in cryptographic system? There are a few problems. Okay, so basically it's not that strong to be used for cryptographic system, because if you look into the formula, if the hacker or the crypt analyst knows about the modulus A and C, then it can predict by using these three values, it can predict the x values and generate the whole pattern. And if it knows only x, x0, x1, x2, x3, x4, then it can use some formula and predict C, A and M, and it's problem. So there are some rules also for that, and some methods like 32-bit thing, in which what you do, you take C is equals to 0 and your M is nothing but a prime number. Okay, I'll just write prime number. So here what happens, so M is taken as 2 to the power of 31 minus 1. Okay, 2 to the power 31 minus 1. So it's very big, very huge prime number. So you get very big number like 10 or 11, 13 digits like that. So you use that in this same formula. So it will be like x n plus 1 is equals to a into x naught mod 2 to the power of 31 minus 1. Okay, that you can just write like this and finish the explanation. The main thing, like 1 or 2 lines which you have to write, that will be provided in the notes. So we'll move to the Blum Blum Shub. So this thing is way better for security and for cryptographic system than this linear congruential number, generator. But here the problem is like kind of slow, and it just produces one bit at a time. Here we are producing random numbers, pseudo random numbers. Here we will be producing bits, either 0 or 1 for every number. So here we use P and Q. P and Q are nothing but prime numbers. Okay, so we have to select 2 prime numbers, and such that if you divide those P and Q by 4, the remainder should be 3. For example, if you take 7 and 11. If you divide 7 by 4, the answer is 1. We are taking integer, right? Not float. The remainder is 3. 4 2 is the 8, minus 11 minus 8 is 3. So remainder is 3, like that. Okay. Then what, talking about n. N is nothing but the way you are using mod m over here. You are using mod n here. N is equals to p into q. So you have to take 11 into 70, that is 77. So n will be what? 77. And basically p is, approximately p so equal to 10 to the power of 150 and n 10 to the power of 1 300. Okay, digits, like, can vary to up to those many digits or number. So now what you have to do, we have to take s is a seed. We have to select a number in such a way that, so we got 77, a prime number, not in the sense it is divided 77 x apart from p and q. It shouldn't be divided by any other number other than 1. Same goes with s. S shouldn't be divided, it shouldn't be divided by any number apart from m, such that greatest common factor of s and n should be 1 apart from p and q. Okay. So now we can start. So what is the formula? X naught is equals to s square mod n. This is the first step, because we have to find x1. In order to find x1, we need to calculate x naught. So x naught is calculated like this. After that, it's just write simply loop for 1, loop for I from x to is equals to 1 to infinity. So we just looping the same formula. Instead of s, I'll be putting the previous number. So see here, xi. So here this xi is nothing but xn plus 1 is equals to xn square mod n type, just like that. We are not using this formula here, but just for your understanding. So xi is equals to previous x value square mod n. Okay, so n is that number, right? And then what I will do, this is the Blum Blum Shub of bit. So b of I is nothing but what value I got for here, that I will be modding with what? 2. We will understand in the examples here. X naught, all steps, x naught is equals to s square mod n. Just take a number. If you take 5 also, we have to take in such a way that it's prime, right? So let us take 5. 5 square is nothing but 25. So okay, mod n, 25 mod 77. So it's 25 itself. So x1 is equals to what? X naught, 25 square mod n. So 25 into 25, what is it? 625 if I'm not wrong. I think it's even more. Mod n divide like that, you have to go on. So now if you got the value of x1, you just do it with mod 2. So either you get 0 or you get 1. Okay, because it's very simple, right? Any number if you try to divide by 2, we'll take one example. Let us take 11, 15, 20, 30, 33. If I divide by 2, 2 tens are, so remainder is 1. Here 2 sevens are 14, remainder is 1. 2 tens are 20. Okay, here 2 fives are 10. Okay, so here remainder 0, 0. If it is even number, it is 0. If it is odd number, it is 1. So here we are getting true randomness. In the textbook there is a diagram. If you look into that, you'll understand. You just have to remember these formulas, and the steps are here like that. If you just look into textbook now once, you will understand this concept very easily. I hope you understood this problem, this concept. It's very simple and easy concept, okay? So you don't have to worry anything about that. By chance, if they ask only one of it, and like for 7 marks or 8 marks or 9 marks, do not worry, talk about random numbers, pseudo-random numbers, and about this, who invented this, or why was this invented, to talk about all the numbers, expand a little, talk about the formula, talk about the steps. See, it's very simple, right? If you just use these numbers, explain, and you can simply write multiple steps. Here I have just erased and wrote. So if you explain all the steps here, what is happening, it can go up to 2 pages. I write all the numbers, talk about the rule I said, right? See, it should generate 0 to m, all the numbers, no repetitions, randomness, etc, etc, advantages, limitations. So they itself, you can write easily for 10 marks. So that's not a big problem. Same goes for this. So I hope this explanation was useful, and kindly do like and subscribe. We'll see in the next video.